Types of seismic waves. There are three kinds of seismic waves: P waves, or pressure waves, sometimes also referred to as primary waves because they're the fastest. So you can make these in a slinky, for example, by pushing a compression into the end of the slinky, and it will travel down through the slinky as a series of compressions and expansions. So in this case, if you were to look at one loop of the slinky, you would see that the loop of slinky would move back and forth along the direction of wave travel as the wave goes from left to right across the diagram. The properties of the P waves would be they tend to be high frequency and small amplitude. And of course, they're the fastest waves. They will be the first ones to arrive from a distant earthquake. Next fastest would be the S waves, or shear waves, also referred to as the secondary waves because they're the second fastest. We can make these in a slinky or in a rope by just throwing a loop down the rope. And what you'll notice is that the particles move up and down as the wave travels from left to right across the diagram. Properties of the shear waves would be that they have slightly larger amplitudes than the P waves and slightly longer periods or lower frequencies than the P waves. Slowest of all the waves would be the surface waves. And these are so named because the maximum amplitude that they produce is at the surface of the Earth. The amplitude of oscillation of the Earth decreases as you go into the Earth, so that by the time you get down to 40, 50, or 60 kilometers within the Earth, these surface wave amplitudes have died away. On the left-hand diagram here is shown the motions of the love wave, where the surface of the Earth moves vertically or horizontally back and forth as the wave travels from left to right across the diagram. The Rayleigh wave has both vertical and horizontal motion. It's a kind of a rolling motion of the surface of the Earth. And again, the amplitude of oscillation dies off going down into the Earth. The surface waves have longer periods, substantially longer periods than the P wave and the S wave does. So these would tend to have the maximum energy in periods of 5, 10, or even 20 seconds. And those periods tend to be very damaging. That kind of ground oscillation in those periods tends to be damaging to large structures. So although these surface waves are the slowest waves, they will arrive last from an earthquake, they pack a punch, and they are often the most damaging of the seismic waves generated by earthquakes.